Hello students, we have the demand for the potentiometer. So let me discuss in short about the potentiometer. Now what is potentiometer? In short, very easy language, we can say potentiometer is nothing but a sophisticated voltmeter to measure the voltage or potential. Simply, it is a sophisticated voltmeter just to measure the voltage or potential accurately. Now the question comes, when voltmeter is available in the market, why should we go for the potentiometer? The reason is that voltmeter have some finite resistance. So whenever you want to measure the voltage or EMF of a battery, this voltmeter will draw some current from the battery and automatically exact value of voltage and potential you will not get. But in case of potentiometer, I will not show how, because we will discuss this point, how I will discuss. So with the help of this potentiometer, whenever we measure the potential and voltage, then you will find you will get the exact value of the potential or the EMF of the battery, because the current drawn by it, that will be cancelled by a ratio method. In that particular cases, the difference is that voltmeter draws the current directly and it will drop the exact voltage of the battery. But in case of potentiometer, this question will not arise and automatically will get the exact value of voltage or potential of a battery. So what is the summary? Summary is that potentiometer is an instrument where we use the Wheatstone bridge principle, and with the help of this, what we measure the exact value of voltage or EMF of a battery. This is potentiometer. Okay, now see the structural construction of a potentiometer. Actually it is this type of instrument. Suppose these are the wires. Each wire is of 1 meter, so I am showing you 4-meter wire is the fastened in this way, and it is placed on a board. Okay, after that you add a battery with it. That means this battery voltage V, that will be dropped over this total wire of the potentiometer. Okay, now another voltmeter. Suppose this is a voltmeter. This voltmeter, when we connect it here, suppose, then this much length, there will be a voltage drop, because due to this battery from positive to negative I current is passing, and this portion have some resistance, suppose R. So what will be the voltage drop? V equal to I into R. So this much voltage will be dropped, and that will be shown in the voltmeter. So with the help of this voltmeter, you can measure the voltage drop of this length. If we connect it here, then we can measure the voltage drop of this much length. In this way, with the help of length, you can measure the potential like this. Okay. Now the point is that with the help of this instrument, whenever we measure the potential, then it depends upon the length. Let me show in just like this type. Suppose I make one this type of instrument. This is suppose one very easy example of a potentiometer. See, these are the wire, as this is fastened like this. At the two end you add the battery, so that the battery voltage will be dropped over the total wire. Now it is a voltmeter. Okay, connect this voltmeter from here. This voltmeter, the pointer, you can move from everywhere. So when you touch it here, then suppose we touch it here, then this much length, the voltage drop over this length, that will be shown by the voltmeter. Okay, in this way you can measure the total voltage of a battery. If I add one galvanometer and battery, I'll show how to measure. Then you can find out the EMF or voltage of a battery. But the basic construction is that whenever this potentiometer is there, this is the total wear, voltage of this battery will be dropped over the total wear. Okay, now when you touch it here, then the voltage drop for this length will be measured by this voltmeter. If you connect it here, then that voltage drop over this length and this length, this total length, the voltage drop, that will be measured by the voltmeter. So this is one basic model of a potentiometer. Okay, now come to the point how to use the potentiometer and where we will use it. Just let me show it. Potentiometer will do. First of all, let me discuss this one potentiometer to compare the EMF of two cell. That means there are two cells given. The EMF of one cell is known, other is unknown. Now with the help of this potentiometer, you can make one relationship at the end, the ratio between these two EMF. Now one EMF is known, you can easily find out the other EMF. In this way you can measure. Okay, so there are two use. First use I will show you the comparison of the EMF of two cells. Just let me draw the structure, your circuit. So this is your potentiometer. Suppose whatever be the length, 400 meter, 600 meter, because 1 meter length is there, so it is 100 centimeter, 200 centimeter, 300 centimeter, 400 centimeter. In this way length can be measured. Now the point is that in case of this battery voltage V, if we connect it here, this is voltage V. Now this voltage V, and here is the battery. Now in this particular case, the battery, suppose this battery EMF we have to measure. This EMF is to be measured, and with the help of this, just let me make the theory first. Suppose now see, first of all, use one galvanometer here, and this is the moving jockey. Now if we move, see, now the point is that this voltage will be dropped over the total length. Now there is another battery E. So there are two batteries. Battery voltage of these placed on the wire, and this is our experimental battery with a galvanometer. Suppose if I touch the galvanometer here, we get a null point. Null point means galvanometer deflection 0. What does it mean? It means that the voltage drop for this much length only, this much length, this voltage drop should be balanced by the voltage of the battery E. That's why galvanometer shows the null point. I'm telling you again. Suppose after touching this point in this circuit, if we get the null point in this position, suppose the length is, let me draw the name, suppose the length is L. For this L length, you are getting the null point. What does it mean? That the voltage drop over this L length, say for this L length, is equal to the voltage drop of the battery EMF E. In this way you can measure. So you can write the EMF E should be is equal to voltage drop of this L length. Suppose the resistance is R, so it is I into R. But we know that R is equal to rho L by A. This is the L, this length, this much voltage drop. So what it shows that E is proportional to L. I is constant, rho constant, A constant. So that means EMF can be measured in terms of the length. This is the basic principle of a potentiometer. So before going to this comparison method, they may ask one question: what is the basic theory of the potentiometer? This is the basic theory. That means EMF is proportional to the length of the wire. I am repeating once more that this voltage is dropped over the total length. There is another battery, experimental battery E, with a galvanometer, and if we move the jockey and if I touch it here, suppose we are getting the null point. It means that the voltage drop of due to this battery over this section is balanced by the EMF of the battery E. So in this way you can equate these two. So this EMF E should be voltage drop over this length. If the resistance of this section is R, so it is voltage drop I into R. E is equal to I into R. But R, we know that R equal to rho L by A, already we got. So from there we can get L is the length of the wire, A is the cross sectional area of the wire, and rho is the resistivity. So from there we can get that E is proportional to L. That means we can write E is equal to, sometimes we can write E is equal to K into L. That means we can write that the EMF can be measured in terms of length with the help of a potentiometer. So this is not the comparison method, this is the basic theory of a potentiometer, how to measure the EMF. Okay, now come to our discussing point. What we are discussing, comparison of EMF. So we have to change the circuit little bit. Suppose what we are doing here, comparison of EMF of two battery. That means we need two battery. Okay, no problem. Suppose this is one battery, positive to negative. This is another battery, positive to negative. Now this end, it has another end. Now these two ends are connected here, and suppose this is A, this is B. Remember this EMF E1, this EMF is E2. EMF is E2, and here we have the galvanometer, and this jockey is moving like this. Okay, now the point is that in this particular experiment, what you have to do, there are two batteries, EMF E1 and E2. Out of this, suppose E1 is known. Okay, E1 is known to you. You have to find out the EMF of the battery E2. That is your target. E1 EMF is known. You have to find out what is the EMF of E2. So how to do this one? First of all, you just do this thing. You connect this, suppose it is C point, A and C. If I connect A plus C, A and C are connected, okay. Then say E1 battery, which is known, E1 is known, E1 is known. So E1 voltage is passing, E2 is now off because C is connected with A. And you move it, you are getting the null point, suppose here. Suppose at the length of L1, you are getting the null point. What does it mean? Just now I have done. This EMF E1 is balanced by the voltage drop for this section L1. So we can write that our E1 should be is equal to K into L1 for this one. Okay. And for the now second case, now connect, open A, connect the C with B. That means now B plus C, connect B and C. So when you connect B and C, automatically E1 is now off, only E2 is acting. So when E2 is acting and you are moving this galvanometer over the wire, you want to find out the null point. Suppose by moving, you are getting the null point here. At the point L2, you are getting the null point for this E2 battery. Okay, so we can write our E2 should be equal to K into L2. That is another theory, just like previous one. Now we make the ratio E1 by E2. What is the result? K L1 by K L2. K will cancel, L1 by L2. Now see, this is the last result. From there you can draw your conclusion, because E1 is known, it is known, and by experiment you are getting L1, you are getting L2. So L1 and L2 is known to you, you can easily find out the E2. So that is the way, by comparison method. That's why I said at the beginning that there is a comparison method. That's why resistance will not be calculated in the main calculation. Resistance of the potentiometer will vanish. That is the problem. That was the problem in case of galvanometer. In case of voltmeter, voltmeter have the own resistance included. But here, as we are making the ratio, so whatever be the resistance in the first case and resistance in the second case, resistance of the potentiometer remains same. That will be cancelled each other. That's why in this particular case, in short, just this is a voltmeter. Potentiometer. In this potentiometer connected with the battery voltage V. Now connect the battery E1 with the circuit and you get a null point at the L1. So for E1 is equal to K of L1. That is the theory of potentiometer. When you connect B and C, then E1 is off. Now current is passing through the E2 and you get this is E2 equal to K into L2. And make the ratio, it becomes E1 by E2 equal to L1 by L2. So from there, E1 value is known value, suppose 1.5 volt. L1 you got suppose 40 centimeter. L2 you get suppose 90 centimeter. So put 40 by 90 and here it is 1.5 volt. Easily you can get the unknown value of the second battery E2. So that is the way, by comparison method we can compare the EMF of another cell. If the EMF of a battery is known, we can find out the EMF of the another battery. That is troublesome to calculate with the help of a voltmeter, but in case of potentiometer you can do this one. Okay, and last one, another application is there. Another application is your internal resistance, to find out the internal resistance of the battery. Now to find out the internal resistance, let me recall, already we have done, let me recall about the EMF and voltage once more. To EMF and voltage, you know that when the battery is open, if you measure the energy difference between the two ends, this is called EMF. Okay, and when the battery is connected with a circuit, external circuit, suppose one bulb is connected. Now at this particular point, the energy difference between these two ends, this is called the voltage. Already we have done. That means EMF and voltage, these are very close things. These are nothing but the amount of electrical energy, one in the open circuit, one in the closed circuit. So when the circuit contain any resistance, then it converts into the voltage, and when the circuit have no resistance, then we calculate the EMF. Okay, so this is the EMF and voltage concept. Okay, this is the recall one. So now I come to the next part, that is your, we call the another application. Here what we will do, to calculate the internal resistance of the battery. We calculate the internal resistance of a cell. Cell have its internal resistance, and what is the meaning of internal resistance? That when the battery is connected with the external circuit, suppose bulb, then current passes through this electrolyte, and electrolyte have some resistance, that is called the internal resistance. Electrolyte have the resistance, that is called the internal resistance. So when external circuit is added, only then current passes through the electrolyte, but when it is an open circuit, now see, no current will flow through the electrolyte, and electrolyte have no question to arise any resistance. So internal resistance concept comes only when external resistance is connected. So when external resistance is connected, current will pass through the external resistance and also through the electrolyte. So when the current passes through the electrolyte will oppose the current, that is called the internal resistance. And now our target to calculate this internal resistance of the battery. With the help of the voltmeter, you never calculate this internal resistance. Then you need only the potentiometer to calculate the internal resistance of the battery. Because internal resistance is the resistance of the electrolyte itself. How can we measure with the potentiometer? Just see the circuit. First of all, you take the potentiometer as you have taken previously. So this is a potentiometer of any length. There is scale also, and you add one battery with it. Okay, suppose the battery voltage V connected with it. So this battery voltage will be dropped over the total wire. Okay, now connect one battery. This battery, you have to find out its internal resistance. EMF is E. Internal resistance of this battery you have to calculate. That is your question. Now For this, you do one thing, you add one resistance box. One resistance box of any resistance you connect in this way. Okay. And keep it open, take a galvanometer, just like previous section, and try to find out the null point. This is the structure. So what is the basic difference? Previously it was there are two cell because we have to compare the EMF of the two cell. Now we are not using any two cell, we are using only one cell. This is one cell of EMF E, this is a cell of EMF E, and its internal resistance is to be measured. And for that, what I have done, we use one resistance box, not directly connected, we connected it and we keep on switch here, so that if we connect it, then only the resistance box will be added, and if it is open, then there will be no resistance. Okay, now how to do this work? First work is that you just open it, that means there is no external resistance with the battery. I said that when a battery is in the open circuit, it gives you the EMF, and when external circuit is added, it gives you the voltage. Okay, now see the point here, it is open. When it is open, there is no external circuit with the battery, so now the battery will show you the EMF. Okay, just connect it, start the experiment, and move this your cursor, and it comes here. Suppose this jockey will come here to show you the null point. Suppose the length is L1. So for this length L1, you got a null point. It means that the voltage drop over this section is balanced by the EMF of the battery. Why it is EMF? Because resistance box is open, it is not connected, there is no external circuit, only the battery is there. So only battery means it is EMF. So you are calculating EMF, E is equal to K into L1. This is the first case. Okay, now this step 1 is over. Okay, now come to the second step. Second step, what you will do, in second step you connect the battery, that means you connect the switch, just connect this one. So whenever you connect this second connection switch, then what happens? Now the battery gets one external resistance. So whenever a battery gets an external resistance, it will give you the voltage. I said previously that when the battery is open, no external resistance, then it is EMF. And when the battery with external resistance, it gives you the voltage, because now the current passes through the electrolyte also. So in this particular case, when the resistance box is connected, now the battery with resistance box, whenever this is connected with this external circuit, now it will give you the voltage, not the potential. Okay, so suppose it is V dash. So when you connect it, it gives you the voltage V, suppose. So V, and you are getting the null point in another position now. Suppose you are getting it here at the L2 position, you are getting the null point when we add the resistance box. Because adding the resistance box means we are adding one external resistance with it. Due to this external resistance, now it will give you the voltage, not the EMF. Previously, resistance box was open, you got the EMF, and when we add the external circuit, now you get the voltage, and you get the null point at L2, so it is K into L2. So remember, why it is E, why it is V? Because previously this circuit was open, this switch was open, battery have no external resistance, it gives you the EMF. And in second case, what you have done, you have connected this switch, that means you are adding one external resistance with the battery, and whenever external resistance is connected with the battery, it gives you the voltage. Okay, so again you make the ratio just like previous case, E by V equal to KL1 by KL2. That means we get L1 by L2. Now the point is that from there also you cannot draw the internal resistance, because internal resistance value is not given, it is E and V given. Now okay, that already we have done. In case of voltage, V is equal to I into R, and when we measure the EMF, we say that when the EMF is measured, then the current passes through the electrolyte also, and the question of internal resistance comes. That means then E is equal to I into R plus R. Both the resistance will be added, external resistance plus the internal resistance. That means we can write in this way, E is equal to I into R plus R, and V equal to I into R. So if we put the value, it is I into R plus R. If you forget this thing, you see the EMF and voltage, this note once, you will get this relationship once again, you will understand. And V equal to I into R is equal to L1 by L2. So from there I will cancel. So you get 1 plus R by R is equal to L1 by L2. So from there you can easily solve it. Now let me rub this section so that you can get the value from here. So it is 1 plus R by R is equal to L1 by L2. So from there R by R is equal to L1 by L2 minus 1. Okay, minus 1, or directly R is equal to R into L1 by L2 minus 1. This result will give you the internal resistance. Why? Because R value is the resistance box you have given. The value you have already you have inserted there. So this is the R. L1 and L2 are the null point already we got in two sections. So L1 and L2 are the two null points. If we put the value, we get the internal resistance. So this is a little bit critical circuit, but the point is that very easy to remember in this way, that voltmeter, potentiometer is there. Connect the battery alone, you get the EMF. Now insert the resistance box and you get the voltage then. So EMF by voltage ratio you are getting it. Now after that, this is the section from the EMF and voltage chapters. We know these two relation. Just put the value. In place of V it is I into R. In place of E equal to I plus R plus R. Cancel it, you get this one, and from there just one step more here and here we get the internal resistance. Everything known. R is known, resistance box. L1, L2 are the two null point. Put the value of two null point, you got the value of the internal resistance. So this is the use of the potentiometer. So with the help of potentiometer, I say it again, that is one advantage you are getting. You can measure the EMF. Once if you want to calculate the EMF, don't insert the resistance box, you get the EMF directly. You need the voltage, add the resistance box, external resistance, you get the voltage. So in this way, EMF and voltage side by side you can calculate with the help of a potentiometer. It is impossible in case of a voltmeter. You have to make the separate circuit. But in this circuit, when the resistance box is open, then you get the EMF. And when the resistance box is on, then you get the voltage. So in this way, EMF and voltage both you can calculate with the help of the potentiometer. And one more thing, there is no even the internal resistance of the battery. This can be measured with the help of the potentiometer only. With the voltmeter, you cannot do this experiment. So the internal resistance is simply the resistance given by the electrolyte that can be measured with the help of the potentiometer. Okay, so this about the potentiometer. It is simply like a voltmeter, but accurately you can measure the EMF and the voltage both. Okay, hope you can understand. Okay, bye.